You've been asked to select a positive integer n which is less than 1000. Positive integer n which is less than 1000. That is from the set 1, 2, 3, 4 till 999. That is either a multiple of 4 or a multiple of 6 or an odd multiple of 3. So it either belongs to this set 4, 8, 12, 16 all the way till 996. 1000 is a multiple of 4, 996 will be a multiple of 4. Or belongs to this set 6, 12, 18, 24 all the way till again 996. This lovely 996 is also, it also happens to be a multiple of 6. How so? It's a multiple of 3, sum of the digits. It's a multiple of 2, it's an even number, so done. And 1002 is a multiple of 6, 996 is a multiple of 6. Or an odd multiple of 9, so 9, 27, 45, 63, 81 and so on. So we need to find the number of positive integers that are in these lists. So looking at the formula a plus b plus c minus a intersection b minus b intersection c minus c intersection a plus a intersection b intersection c. It's going to be a long drawn out formula, but one very beautiful thing that we can see here. All numbers here are even, all numbers here are even, all numbers here are odd. So we can keep this aside. It's not going to bother us in any way. Okay. How do we simplify this? Very simple. Find the number of multiples of 4, number of multiples of 6, add those two up. Subtract the multiples of 12 within that list because there will be a certain overlap. Remove that. Once you have removed multiples of 12 from that, we get multiples of 4 or 6 and then add the multiples of 9, odd multiples of 9 sitting here. We're done. Our set C has nothing in common with A and B. If we had to plug into this formula, this will go to 0, this will go to 0, this will go to 0. So we find this and then add this, we are through. 996 is 224 into 4. Sorry, 249 into 4. 250 into 4 is 1000. 249 into 4 is 996. So there are 249 numbers in this set. And 996 by 6, 900 by 6 is 150. 96 by 6 is 16. 166. Number of numbers here is 166. 996 divided by 6. Divide by 3, 332 by 2, 166. And now we need to subtract the number of multiples of 12 sitting here. That is, we need to remove 12, 24, 36 all the way till 996. We need to do 996 by 12. 996 by 6 is 166. 996 by 12 is 83. So 249 plus 166 minus 83. That's where we stand. Or quite simply, it is 249 plus 83. 166 minus 83 is 83. 2, 1, 5 plus 8, 13, 3, 1, 332. Multiples of 4 or 6 gives us 332. Now odd multiples of 9, 9, 27, 45, 63 and so on. The last one is going to be 999. 9 into 1, 9 into 3, 9 into 5, 9 into 7, all the way till 9 into 111. Or in the sequence 1, 3, 5, 7, 9, all the way till 111. How many numbers are there? 111 plus 1 is 112. 112 by 2 is 56. 56 numbers will be there in this wonderful list. And this is 56 into 2 minus 1. 2 minus 1, 4 minus 1, 6 minus 1, 8 minus 1. All the way till 112 minus 1. So 56 numbers. 332 plus 56. Add these two. 888. 388. The number of such numbers is 388. Wonderful question. Very delightful question. We can plug in this and keep it very form-like. But it becomes much simpler if you just look at this and recognize that one of those sets has nothing in common with the other two. Then we can just simplify that and get to the rest of it.